Here we are with the last lesson for this chapter. We're going to be solving multi-step equations and inequalities. We're going to have a couple of special cases in this section. Only a couple problems, but a lot of information. So first off, solve 20 times x plus 250 equals 15 times 2x plus 1, then check your solution. So you'll notice we have distribution on both sides this time. Some of you previously had divided when you saw your distribution. Because it's on both sides, we're going to have to actually distribute. So distribute our 20. 20 times x gives us 20x plus 20 times 250 gives us 50 equals, distribute on the other side, 15 times 2x gives us a 30x, and 15 times 1 gives us plus 15. Now what's different about this problem that we haven't seen in the past is that we have our variable on both sides. Well, in order to solve and isolate our variables, we need to get them both onto the same side. You could go either way. They're positive each time. Personally, I like to keep my variables positive. So I'm going to subtract 20x from both sides. So that's gone, leaving us with 50 equals 10x plus 15. Okay, well since I move my variables to the right, that means I have to move my constants to the left. So subtract 15 from both sides. 50 minus 15 gives us 35 equals 10x. And now we're down to that last step. Divide both sides by 10. And we get 3.5 equals x. If you have moved your variables to the left, constants to the right, you should end up with the same answer. I know you guys like to write it with the x first, so x equals 3.5. Now to do our check, that orange over here. So everywhere that you see an x, we're going to replace it with a 3.5. So 20 times 3.5 plus 250 equals 15 times 2 times 3.5. I'm squeezing it in here, plus 1. At this point, you can start using your calculator. 3.5 plus 2.5 gives us 20 times 6 equals 15 times, if you did 2 times 3.5 plus 1, that would give us 8. Then 20 times 6, 120 equals 15 times 8, which is also 120. It checks out, so we get a smiley face. Okay, so there's just working where we have our variables on both sides of our equations, which we've done a little bit in the past, actually. This is just a little more in-depth problem. Okay, now if we look at this page, we have some special solutions. Some equations have no solution. When this occurs, the solution is the null or empty set, shown by the symbol, the 0 with an x or a line through it, or the brackets with nothing inside. Other equations may have every number as their solutions. In this case, we would call that an identity, and we would have infinitely many solutions. Okay, so dissecting this. First off, vocab word here, null or empty set. That is when you have no solution. They mean the same thing. They're not two different definitions. They both mean no solution. So if we dive into part A, I see I have some distribution. So we're going to go ahead and take care of that. 3 times y gives us 3y, minus 3 times 5 is 15, plus 25 equals 3y plus 10. I see I have some like terms over here. Remember, anytime you see like terms, go ahead and take care of them. So negative 15 plus 25 gives us 3y plus 10 equals 3y plus 10. Now some of you may have noticed something already, but we're going to keep going. Then drop our line down. I see I have a 3y and a 3y. I need to get my variables on the same side. So if I subtract 3y from both sides, 3y minus 3y is 0. So we're left with 10 equals 3y minus 3y is still 0. We're left with 10. This is a true statement. And when we get a true statement with no variables, so our variables canceled each other out, that is when you have infinitely many solutions. Infinitely many solutions. Okay, so part B. Again, I see I have some distribution and nothing I can simplify on this side so far, so we're just going to bring it down. So negative 5s minus 14 equals 4s plus 6 minus 9s. Again, I see some like terms, so go ahead and take care of those. Negative 5s minus 14 equals 4s minus 9s gives us a negative 5s, still plus 6. Again, I see variables on each side. So undo a negative 5s by adding it. They cancel, or they zero. So negative 14 equals negative 5s plus 5s, still 0. 6. So our variables are gone, but this time we got a false statement. Give a little frowny face. When you have a false statement, that is our null or empty set. So there's a couple different ways you can write your solution here. Your answer to the problem. This is not your answer to the problem, by the way. Negative 14 equals 6 or the 10 equals 10. That is not your answer. Your answer here, you could do the 0 with a slash through it. We could do the brackets with nothing in between. Or you could just write no solution. You do not have to write each one of these every time. I'm just giving you all of the different options. Okay, so this is our null or empty set. This over here was our true statement where we have infinitely many solutions for our identity. All right, one last problem for this chapter. Moriella's parents have budgeted at most $575 for her quinceanera. 40 guests have replied yes. The cost of the party room is $75 and party favors are $5 per guest. We want to write and solve an inequality to represent the situation where we are letting F represent the cost of food per guest, and we're trying to find how much can the family spend on food per guest. Okay, so picking some things out. At most, that tells us less than or equal to 575. We have a one-time fee of $75. So whatever we're spending per guest plus 75. And then each guest is going to be getting food, so let F per person, and then $5 per person for 40 people. So for 40 people, we will be getting them food plus a $5 party favor. Okay, so there's our inequality. Now jumping into solving, I'm going to go ahead and distribute. 40F plus 200 plus 75 is less than or equal to 575. I see some like terms here. So 40F plus 275 is less than or equal to 575. I'm going to go ahead and drop my line down. Solve it just like an equation. So subtract 275 from both sides. That's gone. So 40F is less than or equal to 300. Divide by 40. Divide by 40. And F is less than or equal to 7.5. Now we want to go back through and make sure we're actually answering the question. How much can the family spend on food per guest? So at most, $7.50 on food per guest. All right, and there is the end of the chapter.